Okay, welcome back to the second part of section 21.1. And we are learning how to name alkanes. And we learned the first four rules in the first video. And on this one, we're going to continue on, then also talk about a couple of reactions that alkanes are they're typically part of. So rule 5 is just noticing that if something is drawn like this, it's kind of arbitrary how you draw it. I could draw it like that. I could have drawn this CH2, CH2, CH3, and then showed this coming upward like this. Or you could just write it out, CH3, CH2, CH2, CH3. Notice this is not a 3-carbon chain, it's a 4-carbon chain. So you need to notice that if it's drawn like this and you're counting, this is not a propane chain with a methyl substituent. This is just a straight chain butane. So just pay attention to how these things are drawn sometimes. See, if I draw it out like this, I'm going to draw the C at the end here, the 2 position, CH2, CH3, etc. I actually draw out my hydrogens. This depiction is kind of like showing the CH3 down on this side and the H is up here and here. That's still, though, a 1, 2, 3, 4 carbon chain. It's not a propane chain with a methyl substituent because this is all part of the chain. So that's kind of rule 5. And then part of this as well, if we also have halogens as substituents, we're starting to add in a couple more things here. We call them chloro or bromo, for example. So if you see, just like a CH3 group turns into a methyl, a Cl we would call a chloro group as a substituent. So we like to shorten those names. Rule number 6 is we look at this type of molecule, and I'm going to draw this out like this to actually show these a little bit better. Sometimes you'll see this H3C written like that. You'll see me do that sometimes. Just show the actual carbon connection there. So how do we name this? Well, we'd look for the longest chain, and really doesn't matter how we count it, but we could count it 1, 2, 3. That's as far as we can get. Or we can count it 1, 2, 3, or 1, 2, 3. So 3 is the longest we have. So let's say I say this is the 1 position, this is the 2, or the 3. Couldn't I have also called this 1, 2, 3? Notice it doesn't matter how I number this. This methyl group will always be at the 2 position in this compound. So sometimes we, instead of calling this 1, 2 methyl propane, you can just call this methyl propane instead of 2 methyl propane. So this one's not technically incorrect. It's just the point of naming systematically like this is to simplify the process and be consistent every time. So yes, this is at the 2 position, but if you saw methyl propane, just saw that word, methyl propane, and you're like, what the heck, there's no number here. Where is the methyl group? Well, if you draw out propane, C, 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 and then you think, where could the methyl group be? Well, what if I put it on the first position, CH3? Well, I can't put it on the first position because that would actually make this a butane group. So that means I have to put it on the 2 position, CH3. I have to, because I can't add it to the end, otherwise it would make it into a butane. So it's a little bit trickier to draw this without the 2 there. You have to kind of go through that process. But you don't have to have the 2 there. So you pretty much omit information you don't need. But technically 2 methylpropane, that still works, but you'll often see that omitted. So that's the point of rule 6. Finally, rule 7. We are at the end of our rules. So before we were looking at examples where the substituents were the same, right? Like we had 2 methyl groups or something. But what if we have, for example, let's look at this compound here. This is a 1, 2, 3, 4, 5, 6, 7, 8. Nope, that's not the longest we can do. Actually, it's with this 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a nonane. So what are the substituents now? Well, all the substituents would be this, this, and this, right? Because this isn't part of our straight chain. Now it becomes a substituent. So this is the straight chain. Nonane takes care of all that. Now we have to tell where all these substituents are. So this is a methyl group, 1 carbon chain, and here we have an ethyl and a propyl, 3 carbon chain. So where do we put these in our order? Well, what we do is we don't name them by, for example, this is at the 3 position, this is at the 4 position, and this is at the 5 position. We don't name them as 3, 4, and 5. We actually use them alphabetically. So notice we have ethyl first, and then comes M, and then propyl in the alphabet. So we would call this, using alphabetical order, 4 ethyl dash 3 position methyl, and then finally 5 position propyl nonane. So we use alphabetical, not these numbers. We wouldn't say 3, 4, 5, and just we would use whatever this happens to be, 4, 3, 5 in this case, but use alphabetical for different substituents. This would be the same thing for like a chloral group too. Okay, so let's do a little bit of practice. I'm going to go ahead and again, try pausing the video and using all of those rules that you learned. Attempt to name these, and I'll see you in just a second. Okay, welcome back. Let's take a look at these. So, thinking of our rules, well, we need to find the longest continuous chain. That's always what we try to do. So let's look here. This is 1, 2, 3, 4, or 1, 2, 3, 4. Notice it doesn't matter if I do it this way and call this the 2 position, or if I do it this way. I'm going to just do it this way because it's easier to depict. So 1, 2, 3, 4. Again, why did I not do 1, 2, 3, 4? I don't want that because I want to give this substituent the number at the lowest number possible. So I'm going to call this, first of all, 1, 2, 3, 4. That's bute. So this is a butane. Jot that down. And where is the group? This is a methyl group. It's at the 2 position. So 2 methyl butane. Notice though, this is one of those compounds where I could also just call it methyl butane. But 2-methylbutane is just as correct. Why could I leave the 2 off? Well, let's try this. Let's convert this into a structure. Okay, so it's butane. So I draw a 1, 2, 3, 4 carbon chain. And I put a methyl group on it. Where do I put the methyl group? It doesn't give me a number. Well, I have the 1 position, the 2 position, the 3 position, or the 4 position. If I put a methyl group here, I make that into a pentane. So I can't do that. Can't be at that position. So what are my other options? I can't put it here or here because that would extend it into a 5 chain. So that means I need to put it here or here. Notice putting it there or there makes the same compound. Those are the same. If I put it here at the 3 position, notice these 2 compounds are just flipped. You could just turn this one and flip it over, and it becomes this compound over here. So if I flip this over, it's this. It's the same molecule. So I actually don't need to tell you that it's 2. I can put this here or here, and it's the same molecule. But to be consistent, I'd rather just put the 2 here and call this 2-methylbutane. Okay. Let's get this out of the way. Let's check out this next one. How many do I have here? Well, let's see the longest chain that I can form. So if I just look at this one in the middle, 1, 2, 3, 4, 5, 6, 7, 8, Let's try to use this as my chain. Maybe 1, 2, 3, 4, 5, 6, 7. No. What about 1, 2, 3, 4, 5, 6, 7? Nope. So yeah, this is my longest chain. So this is an octane. Jot that down over there. Now I need a number where my substituents are. So we need to number them alphabetically. Let's go back to this one and see why I numbered these as such. Let's see here. That was the 3 position, 4 and 5. Okay, so for this one, how do we get the lowest numbers possible? First of all, for our substituents. If I number them like this, 1, 2, 3, 4, that means we have an ethyl group at the 4 position, and then 5, 6, 7. That means we'd have a methyl group at the 7 position. If I go the other way, though, let's do a different color. 1, 2. That means I've got a 2 methyl now. 3, 4, 5. And now I've got a 5 ethyl. So 2 and 5, that's the way I would want to number this, not 4 and 7. Subtle, but that's the way we do this correctly. That's the way we'd want to do this. So let me erase all this. Yeah, let me just get rid of all this right now. So we're going to number this 1, 2, 3, 4, 5, 6, 7, 8. So that means I've got a methyl group at the 2 position and an ethyl group at the 5 position for naming. So I've got a 2 ethyl, 2 methyl, and a 5 ethyl. Now, how do I put this all together into a name? So when I name this, which comes first, the 2 methyl or the 5 ethyl in front of the octane? We go alphabetically. So E before M. So we have to name the ethyl group first. So this is going to become 5 ethyl dash 2 methyl octane. And there we go. So it takes a little bit of thinking, but once you get all the systematic ways down, you should be able to name these kind of groups. So that's all the naming. Okay, there's checking our work. Yep, 2-methylbutane. And this is 5-ethyl 2-methyl-octane. Good, didn't screw that up. So all of the naming rules are listed out here for you, and these are also in the book. So pause the video, go through these. This is steps 1, 2, 3. Finding the longest chain, and then looking at 4 branches and naming them with ol for methyl, propyl, etc. And how you identify and number them using di or tri if there's multiple of the same substituents. So go through these, make sure you understand the naming rules, and you'll obviously get a lot more practice with the homework and things like that. So last little snippet of this chapter are just a couple reactions. So alkanes we're used to seeing in combustion reactions. We've done a lot of these types of reactions in the past. So notice we have a hydrocarbon plus oxygen to give us CO2 and H2O. This is what we've seen over and over again. That's what I told you guys. That's a combustion reaction. But that is true, but this is like the typical combustion reaction where, let's say you just have a barrel of this and you're burning it in the air with excess oxygen, or this is how your car would do this. So if you have an excess amount of oxygen, you're going to get CO2. However, we do also see if you have a limited supply, if oxygen is actually your limiting reaction, you're actually going to produce carbon monoxide. And this looks like this is an error. Give me 1 second here. This is an error. Good job, publishers. Carbon monoxide. And I'm going to change this because this is wrong as well. This should be 5O2. So it reacts with it into a different ratio here and produces carbon monoxide. So this is an error in your book. It is correct under reactions of alkanes. I'm not sure what happened here. But this is actually what happens for a limited supply. So we actually produce a different component, CO versus CO2. So that's pretty interesting. And yeah, again, these are used as fuels. Methane is this natural gas component. Propane we see in bottles for stoves and using lighting your grills, things like that, and welding torches. Butane you can see in blowtorches, and cigarette lighters use butane. So those are some common ways that we see those fuels as alkanes used. Another reaction we're going to look at is substitution reactions. So elemental halogens, so Cl2, Br2, I2, etc. They're pretty reactive species. You wouldn't want to be breathing in these gases. So they can react with hydrocarbons. Hydrocarbons don't do a lot of reactions like this unless you do something pretty reactive with them. So in two things, again, if you have limited supply versus excess, you'll see different reactions happen. But notice for this one, if you have CH4, so think substitution. This bromine is going to substitute one of those H's. So you're going to get CH3Br. So this looks like this now. As the Lewis structure. And again, a lot of times these dots are omitted. CH3Br, and then you also get HBr, so hydrogen bromide gas. And if you have excess down here, you have another reaction. And let me double check that this is balanced correct, because now I don't trust this. No, this looks fine. This looks balanced. Yep, this is totally balanced. So if you have a lot of the bromine, notice what happens. You can substitute all of these. So now you've got 4 bromines, CBr4, like this liquid now, plus 4 moles of the HBr. So all alkanes react in a similar manner with halogens and in combustion reactions. So those are predictable reactions. So if you see this plus this, you should be able to predict this. Or if you see this plus this, you should be able to predict this. Same thing, you should be able to see this information and predict the actual products there. That's kind of cool. These are actually, we're digging into some organic chemistry that you can actually predict now. So that's what we're introducing in this chapter. So this is some practice here. Again, you can pause the video if you'd like and try out these balanced equations. So this says write balanced equations for A, propane with oxygen in limited supply, and then ethane with bromine in limited supply. And it says you can omit the phases of these. You don't need to predict phases, just kind of try to do those equations. And I'll give you a second to try those, and I'll come right back. Okay, let's go through this. So let's look at the first one, A. This says propane with oxygen. So what is propane? Well, you have to think back to your prefixes. So prop, that's 3. So this is a 3-carbon chain. So if I have 3 carbons, I need to know I fill this up with hydrogens. Now there's no substituents. So what do I get? C3H, 1, 2, 3, 4, 5, 6, 7, 8. That's how I do those to remember those. Or you can remember that it's going to be C to the N, CnH2n plus 2. That's also the formula you can use. So this would be 3, and this is 2 times 3 plus 2. So 6 plus 2 equals 8. So that's one way you could do that as well. So C3H8 plus O2, limited supply. Okay, remember, what should this be? We're not getting CO2, we're getting CO and H2O this time. And then, oh, we got ourselves a whole balancing thing again. So for these, we can come back and balance out our oxygens at the end. This is how I would do these. Balance out the carbons and the hydrogen first, then I can adjust my oxygens at the end. So let's practice balancing again. So I've got 3 carbons over here, so that I know, at least for now, I'm going to need 3 of these. But notice I have 8 hydrogens over here, so I need to put a 4 over here. And now let's see how many oxygens I have. I have 2 over here, and I've got 3 plus 4 equals 7 over here. So if I put a 7, sorry, a 3. Let's see how would I would do that. Because this is an odd number, this 7, this is kind of weird. What I want to do then is just try putting a 7 in front of this and then seeing how that would affect this number over here. So if I have 14 now over here, how do I actually get 14 on this side? Well, I change this to a 6, multiply everything by 2, and this to an 8. There we go. Now what do I have? 14 oxygens, and I've got 6 plus 8 over here, 14 oxygens. So that's how I dealt with that weird odd number there. Now though, what did I do? I have to adjust my carbons now, don't I? So if I've got 6 carbons over here, I need to make sure I put a 2 over here. And now I have 16 H's and 16 H's. So yes, these take a little bit of practice. These aren't super fun to do the balancing sometimes, but when you do more of these combustion reactions, it becomes quite a bit easier. Okay. Letter B. Ethane. Okay, same process. What does eth mean? That means 2. So ethane is going to be C2H. What is the H going to be? Well, it's going to be 2 times the N, 2 times 2, plus 2. So 4 plus 2 is 6. C2H6. And you can test that out too, but just by drawing it. So if you have eth and fill that up with H's, that is indeed 1, 2, 3, 4, 5, 6 H's that would be there. Bromine, so bromine Br2. And this says limited supply as well. Okay, so this is where we're going to just replace one of the H's with a bromine. So C2H5 now, and just write Br. That's how I would write the condensed, kind of the actual formula for that. And that other H is going to hook up with the other Br over here. And balancing wise, this is already balanced because it's a simple substitution reaction. You just swapped this H to a Br and a Br to the carbon chain. Again, if I want to draw that out, it would look like this. We have our ethane over here. And now we've replaced, I mean, it's arbitrary which one I replace, but let's say I just replace this one here. And that one goes over here. And there's our substitution reaction. Okay, that is section 21.1. So, oh yeah, here are double-checked answers for our equations. So we see that carbon can form very long chains in vastly different arrangements, and we have names of or ways of naming them. So we can be very consistent with how we name these carbon and hydrogens. And we have all these rules to actually name them. And this is the summary of the naming rules. More summary of the naming rules. And we actually just looked at alkanes plus oxygen and alkanes plus halogens as a couple of reactions that alkanes are typically involved in. All right, I'll leave you there for now, and I will see you guys next video for section 21.2.